Okay, welcome to lesson 21 of module 4. We will be continuing with writing linear equations given lines. And in the last lesson, we used the slope-intercept form of the line to allow us to do this. So right now what I want you to do is look at example 1 in your classwork and see if you can determine how you could write the equation for this line. We know that every line has a linear equation that describes it. And so let's see if you can do that with this one, or determine what is different about this example from the examples we had in lesson 20. Okay, so I've identified a couple points on this line that are at intersections of grid lines so that I can determine the coordinates exactly. And so I've got -2, 2, and then the 0.54. And between those two, I can pretty easily determine the slope. So the slope would be the difference in the y-coordinates as I move from one point to the next. So as I go from here up to here, now I know the slope's going to be positive. This slope, as I go over, the line rises, and it rises up 2 as I go from y-coordinate of 2 to the y-coordinate of 4. And then the x-coordinate along the horizontal direction, I'm going to go from -2 to 5, so that's a change of 7. So my slope is 2/7, and that's in simplest form. So I'm going to leave it like that. Then I need to determine, if I'm going to use slope-intercept form, I need to know what my y-intercept is. And that's where the difference comes in with this problem, is that the y-intercept is right here between 2 and 3. So it looks like it's around 2.5, but I don't know what it is exactly. But I'm going to show you, and maybe you already figured this out, a way to determine what the y-intercept is exactly. And we're going to use algebra to do that. Okay, so we've got the equation y is equal to mx plus b, and we know our slope, so we can put that in. If we knew our y-intercept, we could just plug it in right now, but we don't, so I'm going to just leave it as b. So it's y equals 2/7 x plus b. But I do have some other information that I can use. I have at least 2 points. There's actually maybe more that you could find, but 2. And so what I'm going to do is I'm going to just put in for xy into this equation one of my points, and you can choose either one. I'm going to go ahead and choose the 5, 4. So I know that when y is 4, that x is 5. So I can put 5 in for x, and then I can solve for b. So now I only have one unknown in this equation, and so I can go ahead and work it out. So I've got that 4, which I'm going to rewrite as sevenths. So 4 is 28/7 is equal to 10/7 plus b. Okay, so we can subtract 10/7 from both sides of that equation, or we can just look at it and realize that b has to equal 18/7. So b is equal to 18/7. And so now we have b, and we have the slope m, so we can use y equals mx plus b and write our final equation. So y is equal to m, 2/7, times x plus 18/7. And let's check that to make sure it works, that it makes sense. We said that our y-intercept should be between 2 and 3. Well, 2 would be 14/7, 3 would be 21/7. So 18/7 is a real reasonable result for what b should be in this equation. Okay, now let's look at example 2, and go ahead and pause the video and work on this one yourself, and then I will quickly step through the solution. So if you're still fuzzy on what to do, you can just keep playing the video. Please take notes, or try it yourself and see if you can get this one. Remember, think about whether the slope is going to be positive or negative before you get started. Okay, so looking at this example, the first thing I want to do is find a couple points that I can determine the coordinates of, the exact coordinates. And on this line, I found -1, 4 and 4, 1 to work really nicely. And if I want to figure out the slope, I'm going to take the difference in the y coordinates. So I've got the y coordinate here, 4, minus the second y coordinate, 4 minus 1. And divide that by the difference in the x coordinates. So I've got -1 minus 4. Notice since I started with this point, -1, 4, I kept it in the first position both times. That will give me the correct sign on my slope. All right, and so if I straighten that out, I'm going to get 4 minus 1 is 3, -1 minus 4 is -5, so that gives me a slope of -3/5. So now I know the slope, but once again, I can't determine the y-intercept exactly. I know it's right in here between 3 and 4, but I can write the equation of that line as y is equal to -3/5 x plus b. And since I have this additional information of these points here, I've got a -1, 4 and a 4, 1, I can choose whichever one of those I want to put in for my y and my x values. Okay, so I know when y is 1 that x is 4. So I put in 1 for y and I put in 4 for x. That gives me an equation I can solve for b. So let's straighten that out. I'm going to write 1 as 5/5 because I know that eventually I'm going to have to combine it with this fraction over here. So 5/5 is equal to -12/5 plus b. Just multiplying this out right here. Okay, I'm going to continue up my next step up on the next column. So I've got, now this time I'm going to add the 12/5. I've got -12/5. So if I add 12/5 to it, that's going to leave b by itself, and that's what I want, so I can solve for it. So what I've done is added 12/5 to both sides of this equation. So I end up with 17/5 on the left, and then I end up this becoming 0 and end up with just b on the right. So b is 17/5. So what I want to do now is put that in my slope-intercept form of a line, my equation, and I just need to substitute for m and b. So now I already had the slope, -3/5. Now I know the y-intercept, 17/5, which, by the way, if you think about this fraction, it's a little bit more than 3. Looks like it's 3 2/5, so right about 3.5, which makes a lot of sense with our graph right here. So that's always a double check. You always want to do that. So I'm going to substitute m and b into this equation, and I'll get y is equal to -3/5 x plus 17/5. And that will give me all the other solutions on this line. You could even check a few. If you put 0 in for x, obviously if you put 0 in for x, you get 17/5 here. But you could try putting in, well, you could put in these points, surely that would work. But you could put in something like 3 for x and solve and make sure that it looks like it's a solution. So that's another good double check on these problems. Okay, now you can work on example 3 on your own. This example shows only a portion of the coordinate grid, so we're not even able to see the scale on the y-axis. So I'm going to tell you these are all standing for 1 unit. So the x-axis is going by 1 unit, so we're going to use the y-axis as 1 unit as well. Okay, so see what you can do with that one, and then come back and I will quickly go through the steps to solving. All right, so once again, the first thing we need to do is determine some points. So I found the points 12, 2 and the point 13, 7. And I want to use those 2 points to determine the slope of this line. And so I'm going to look at the difference in the y coordinates and divide that by the difference in the x. So I get 7 minus 2 divided by 13 minus 12, which comes out to 5 over 1, which simplifies to just 5. So I've got the slope of 5 for this equation. All right, and so once again, the y coordinate, not only can I not read it, but it's way down here on the graph, and so it's not even on this part of the grid, so I need to solve for it algebraically. So we're going to start with that. So we don't know what b is, but we know that this line can be written as y equals the slope times x, so y equals 5x plus b. And I have some points here, so I chose to plug in the point 12, 2. You might try this and realize that if you put in 13, 7, you'll get the exact same result for b. But I'll show you the steps for doing it with 2 and 12. So multiplying out 5 times 12 is 60. We get 2 is equal to 60 plus b. And in order to get b by itself, I'm going to use, so I'm using properties of equality here. So I'm just subtracting 60 from both sides. And I get 2 minus 60 is negative 58. And on the other side, 60 minus 60 is 0, so I'm just left with b. So negative 58 is b. So now I have my slope m, and I have the y-intercept b, so I can plug it into this equation and get my final equation for a line. Y is equal to 5x minus 58. Because my b is negative, that ends up being a subtraction here. So again, this equation here is going to give me all the solutions for that would lie on this particular line. So y is equal to 5x plus b. 5x minus 58. Okay, example 4 gives you just another chance to practice your skills here. This one is actually quite simple. So go ahead and work on it, and then I will just give you the result. Okay, so the points that I chose are 0, 0 and the point 3, 1. That gave me a slope calculation where I subtracted the y coordinates and I got 1 minus 0, and subtracted the x coordinates 3 minus 0, or I could just note that the rise is 1 for a run of 3, so 1, 3. So the slope is 1/3. My y-intercept is 0, so this one is pretty simple to do. I don't need to solve for b. I can just see that the equation of this line is y equals 1/3 x. Okay, so we're just going to take a couple minutes to look at another format for writing the equation of a line, and it's called point-slope form. And first we're going to look at the way most math books are going to label points on a line. So normally they're going to use these subscripts, and they're going to write x1, y1, x2, y2. So these are just 2 points on a line. So if we're given 2 points, then we know we can write the slope. And the slope is called m, and that's pretty standard across the board. And the slope's a ratio, right? It's the ratio of the difference in the y coordinates, or what we call the rise, divided by the difference in the x coordinates, or the run. And so this would be the conventional way to write the formula for slope. But remember, knowing the meaning is what's important, not how it's labeled, but what it actually means. This idea of the difference in the y over the difference in the x, change in y for a given change in x, it's this ratio. Okay, So, but if we have the slope written in this format, we're going to use that to write the point slope form of a line. So I'm going to put parentheses around there so we can see that those are quantities. And then we're going to multiply both sides of that equation by that quantity x2 minus x1. And we get this, this equation. We've just written an equivalent equation here. And then if I'm going to substitute for one of those points just our general xy pair. So this x2, y2 is just going to become my variables xy. So this is the point slope form of an equation. And so what I need to use that format is a point and a slope. So that's why it's called that. So if I know the slope m and I know one point, x1, y1, I can put that information, I can put the coordinates of x1, y1, and I can put the slope, and then I have my linear equation here for that line that has that slope and goes through that point, which we know there's only one line that would do that. So that would be the equation of that line. Okay, so that's point slope format for an equation. We have been using slope intercept, right? So we know that if we have the slope m and the y-intercept b, that I can just put that information into this format and I get the equation of the line written like that. Okay, so let's just kind of label those things. So we've got slope intercept, we've got point slope. So the important thing to realize, and what we've been seeing here, is that if we have the slope and one point, we can write the equation of a line. Or if we have 2 points, we can write the equation of the line. Because think about it, from 2 points, we can find the slope. So really it's the same as having the slope and 1 point. So at any rate, we're going to look at the exercises now and give you a chance to practice writing the equation given the information about the line. Okay, so you can complete exercises 1 through 5 independently and then come back and check your work. I'll go through some sample solutions quickly on the screen. Okay, so for exercise 1, once again, the first thing I want to do is identify those points on the graph. When I'm given a graph, identify 2 points that I can use to calculate the slope and to write an equation for that line. So I took these 2 points and I wrote the slope as the difference in the y coordinates. So I've got -3 minus a -1 divided by the difference in the x coordinates. So I've got -1 minus a +5. And so when I do the math on that, -3 minus a -1 is -3 plus 1, or -2. -1 minus 6 gives me, -1 minus 5 gives me -6. And I can see those quantities on that slope triangle there. And I get a slope of +1/3. Negative divided by negative is positive. And I wanted my slope to come out positive because I can see that that's a line that is sloping up as I go from left to right. So slope of 1/3 makes sense with the slope triangle I've drawn here. Okay, so then I'm going to go ahead and use the slope intercept form. Y equals 1/3 x plus b. And I'm going to put in one of my points. I chose the point -5, 5, -1. So I'm going to put 5 in for x and -1 in for y. And now I can solve for my y-intercept because this is a situation where I can't read the y-intercept directly off of this graph. I know it's between -2 and -3, but I can't find its value directly, so I'm going to use algebra. Okay, so I'm going to write -1 as -3/3, and then I end up with 5/3 plus b on the right-hand side of that equation. And then continuing up over here, I'm going to subtract 5/3 from both sides of that equation, and I will get negative 8/3 is equal to b. Once I've done that, then I have the y-intercept, and I already had the slope, and I can write the equation of that line as y is equal to 1/3 x minus 8/3. And once again, I always like to check my y-intercept. Negative 8/3 would be a little bit less than -3, or a little bit more, actually. It would be between -2 and -3. So that checks out, and I can even check another point here. Like I should be able to put in the coordinates of the point 2, -2, and that should work in here. So yeah. Anyway, so that is exercise 1. Okay, exercise 2 is very similar to exercise 1. We're given the line, so I'm going to identify a couple points, calculate the slope between those 2 points. Okay, and this is another case where I don't know the y-intercept. I can see that it's between 7 and 8, but I can't determine it exactly. So I'm going to put what I do know into slope-intercept form. I'm going to use the point 2,8. Remember, I could use any point on the line that I want. Put it in for x and y, and then solve for b. And when I do that, I get b is equal to 38/5, which is more than 7 and less than 8. And I'm going to use that information to write, along with the slope, to write the equation of that line in slope-intercept form. So that would be y equals 1/5 x plus 38/5. Okay, exercise 3 seems a little bit different because we're not given the graph, but they've actually just done some of the work for us and given the coordinates of 2 points, which is where we would have started anyway. So with the coordinates of 2 points, I can figure out the slope. So the slope is the difference in the y divided by the difference in the x coordinates. So I've got 5 minus 3 divided by, so what do we got? We've got 5 minus 3 divided by -4 minus 2. And if I do the math, I get 5 minus 3 is 2. -4 minus 2 is -6. And that simplifies to a -1/3. Okay, so I want to take a second just to show you, because a lot of times students say, well, I don't know which point to put first and which one to put second. And here you can see it doesn't matter. If I express the difference in the y as 3 minus 5, then the difference in the x would be 2 minus -4. And when I sort that out, I get 3 minus 5 is -2. 2 minus -4 is +6, because that would be +4. And in the end, the result is still a +1/3. So whichever direction I want to go, the slope is still going to be a +1/3. That should be a positive right there. I mean, -1/3, sorry. This should be a negative right here. Where do we go here? Right here, -1/3. Different ways to write that, but that would be a -1/3 slope. Okay, sorry about that. Okay, so knowing the slope is -1/3, I'm now going to use the slope-intercept form and put that information in. Again, we don't know the y-intercept because we weren't given that point, but we can figure out what it is using this equation. So I'm going to use the point 2, 3 right here and put in 2 for x and 3 for y. And now I'm going to solve for b. So I'm going to express 3 as 9/3 because I noticed that I'm going to get a -2/3 when I multiply that out plus b. I'm going to add 2/3 to both sides of that equation and see that b is equal to 11/3. So now that I have the y-intercept, I can write the equation of that line. y is equal to negative 1/3 x plus 11/3. Now, if I wasn't sure about my result and I wanted to check it, here's a really good way to check it. I'm going to take this equation, y equals negative 1/3 x plus 11/3. Let me get this here, get some room. So given this equation that we came up with, what I want to do now is I want to plug in or substitute the other point that I haven't checked yet, negative 4, 5, into this equation. I'll put in 5 for y and negative 4 for x, and just check out to make sure it's a solution. If that's a solution to this equation, then I can be pretty sure that I got this equation right. And so I'm asking myself, is this a true statement? And then this point would be a solution to that. So I get 5 is equal to positive 4/3, because I got a negative times a negative again, plus 11/3. And we can see that 5 is equal to 15/3. And so that checks out. That is a solution. So that's just a double check you can do if you want to be especially sure, like on an assessment, if you got it right. So there you go. Okay, let's look at exercise 4. This one is just the same as the others, so I'm not going to go through an explanation of this one. Just the result you should have gotten is y is equal to negative 4x minus 26. Okay, let's see. So our last example is exercise 5. Here it is, which says that a line goes through the point 8, 3 and has a slope of 4. Write the equation that represents the line. So once again, we don't have the graph, but we have really more information than the graph usually shows us because we already know the slope. We know that the slope is 4 and we have a point, so we're going to put that into slope-intercept form. So I would have y is equal to the slope times x plus b. And now, once again, I'm going to put in my point. Y is 3, x is 8, so 4 times 8 plus b. So I have this, and then if I subtract 32 from both sides, I'm going to get negative 29 is equal to b. And so I can write the equation of that line. That line would be y is equal to 4x minus 29. And that would be the equation for that line. Okay, so just in summary, we can see that you can see here the formula for the slope that we said is kind of the general one that you'll see in most textbooks. This is what's known as point-slope form. It's not used near as much as slope-intercept form, which seems to be the easiest way to find the equation of a line given either 2 points. So down here, given either 2 points or the slope and a point. And if we're given the y-intercept, we can just plug it right in there. So to write the equation of a line, you must have 2 points or 1 point and the slope or the graph of the line. And if you have the graph of the line, of course, you're going to have to find 2 points to write that equation. So you have quite a few tools now to write equations for lines. So you are ready for the exit ticket and problem set for this lesson.